Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels, kindergarten, Pearson I Primary Certificate, secondary and Pearson IGCSE certificates.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then of course in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in our learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Mohammed and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.
Hello everyone, this is Madam Naomi in Horizon TV, and this is Andalusia Academy. Welcome to today's episode, Physics Episode 2. You remember last time we were looking at electricity, and we learned about current, voltage, and we calculated both of them. So for today, we're going to continue with the same topic, but a different subtopic, and it's under electrical circuits. So this is physics. So today we're going to continue with the same topic, but we're going to look at different subtopic. Yeah, we're still under electricity, and for today we're going to look at electrical circuits. It's the still same concepts. You remember last time we differentiated between series and parallel circuits, and we say that under series circuits the current follows one path. But under parallel circuits, we say that the current flows through junctions and branches. And for today, before we continue, I know we're going to narrow down to resistance and the units and the calculations. So for today, I want us to start with the electrical symbols, electrical component symbols. We're going to look at the symbols which are used in electrical circuits, meaning different kinds of symbols. And we're going to start with the common one. We're going to start with the common one, which is a bulb. This is the symbol for a bulb. Yeah, this one is a common one. You've seen it, we've used it in the previous lesson. Yeah, this is a bulb. And the second one we're going to look at is the voltmeter. I told you last time this one we used it. This is a voltmeter. And of course we looked at the ammeter. This is the ammeter. You remember we had used it last time, so I just want to do a summary and to add you some more symbols of different electrical components. And we're also going to look at the resistor. This is a resistor. This is a resistor. And we also have a variable resistor. This one is a variable resistor. And we also, there are two components which usually confuse students, a cell and a battery. Yes, so this is the cell. This is a cell. This one is a cell. And we also have a battery. There is a difference between a cell and a battery in that a battery comprises of two or more cells combined together. So we have this one is our battery. This one is our battery. Okay, as we be moving from one subtopic to another, studying different electrical components, you're going to realize we have so many of them. But for today, I just wanted to mention the commonly ones. The common ones, the one we're going to use to commonly use here. And we're also going to look at the thermistor, all of them. But I don't want us to mention all of them. Yeah, we're going to narrow down and look at different components, and you're going to be used to using these symbols in all the electrical circuits. So for today, I wanted us to study resistance, to calculate resistance, to look at the components which have high resistance and low resistance. So we're going to narrow down to resistance. Yeah, so we're going to narrow down to resistance. Yes, each and every electrical component offers some resistance to flow of charges. You know, there are some components which make it very difficult for electricity to flow. How? That they make the flow of charges to require so much energy. Yeah, so those kind of electrical components, we say that they have very high resistance. And we also have those components which don't make it make the flow of charges to require large amount of energy. Those components are said to have low resistance. And you realize that most of our connection we use wires. You know that you can see the size of wires, very thin wires. And when I talk about the wires, I wish I had a wire here. Let me check. I think let's just use this one. Yeah, this is, you know, most of the people, you know, when I've been growing up, I used to think all of this is a wire. No, when I talk about a wire, I mean the one which is thin, which is inside. I wish I could destroy these earphones, but I cannot. Yeah. So inside here, there is a small wire, which is maybe silver kind of, different colors. Of course, we have different colors of wires. So whatever you are seeing here, this is a casing, and it is in plastic or other rubber because of insulation. Yeah, you know you require to insulate this electricity for our own protection. Yes, so we use wires. We use wires for electricity connection because wires offer low resistance. So most of the time you can be asked, why do we use wires? Yeah, so for resistance here, I've said we have components with high resistance. And I said in these components, you realize that for the charges to flow, they require so much energy. Here, for the charges to flow, they require large amount of what? Energy. They require large amount of what? Of energy. And you remember last time when we were defining current, we said current is the flow of what? Charges. And we narrowed down and we said voltage. Now voltage, this is the amount of energy with which these charges flow in electrical components. Now, and we also have components with low resistance. And here, I'm just going to be specific here, wires. We use wires for electric connection because wires have very low resistance. So wires are thin. They are thin and have low resistance. So what measures this resistance? And whatever measures resistance, we're also going to calculate resistance. Yes, so a resistor is the one which measures what? Resistance. A resistor measures what? Measures measures resistance. Yes, a resistor measures resistance in amperes. Of course, this is the symbol for our resistor here. I drew it here. And I hope it's clear. You know, I'm not good at drawing, but I can sketch. Yes, so a resistor measures what? Measures resistance. And what are the units of resistance? What are the units of what? Resistance. Units of resistance. The units of resistance is ohms. It is ohms. Sorry. Yes. The units of resistance is ohms. Ohms. And this is the symbol for ohms. Yeah, we're going to come across this one severally. Even as we move, the higher we're going to move with physics, the more you're going to come across all this. So you might be required to be very familiar with all this. Yeah, so these are the units for measuring resistance. And so we're going to calculate resistance. What is the formula of calculating what? Resistance. Calculating resistance. What is the formula for calculating resistance? You remember last time I gave you this kind of formula and I told you we're going to use it here. Yes, voltage is equals to current multiplied by what? Resistance. So basically resistance is equals to what? Voltage divided by current. And my students, I usually give them, encourage them to use this. It makes their work easier. Yes, this triangle here, where we have resistance here, voltage here, and current here. From this formula, you can calculate several units here. You can calculate voltage by multiplying resistance multiplied by what? By current. Yes. So you can use this one. This one is very simple. We're going to narrow down to examples. We're going to use some two examples here. Examples. And I'm going to write all the examples here. So example one here. We have the voltage across a light bulb. The voltage across a light bulb. The voltage across a light bulb is 12 volts. Calculate the electrical. Is 12 volts. It's 12 volts, comma, and the current is 2 amperes. I hope you remember all the units of voltage and current. Of course, volts and amperes. Calculate its resistance. Yes, I told you earlier here, we calculate resistance by dividing voltage divided by what? By current. What's our voltage here? Our voltage is 12 and our current is 2. So when you divide this, you get what? 6 ohms. You make sure you write all the units. You know, sometimes you can miss to write the units and you will be penalized. So it's good to write the units. Yes. So this is how we calculate resistance. I'm going to the next example, and here I'm going to use two resistors which are connected in series. Last time, you remember when we were talking about series and parallel connection, we said under series, when two bulbs are connected in series, what happens to the current? The current is same. I can just revisit on that. For example, let me just sketch this one roughly. Let me just a reminder. When we have bulb A, when we have bulb A and B, I said last time, when current is flowing here, the current in bulb A and bulb B is all the same. So for example, here is 2 amperes. This one is also going to have what? 2 amperes, which is not the case in parallel. Yes, so I'm going to give you an example too, but I'm going to give you 2 resistors. And in these 2 resistors, I'll want you to calculate the voltage and the what? And the resistor, the current. Yes, so we have two resistors here. Sorry, we have 2 resistors here. Of course, this one is a battery. I hope you cannot confuse with the cell. We have 2 resistors here. We have 2 resistors here. This is a symbol for a resistor. And the voltage across this battery is what? 12 volts. And the first resistor has a measurement of 2 ohms, and the second one 4 ohms. So the first question you can be asked here, question A, you can be asked here to get the current, calculate the current in each of the resistors. Calculate the current in each of the resistors. Yes, so you can be told calculate the current in each of the resistors. And I told you when we're having 2 components connected in series, what happens? The current is all the same. Meaning here if you get 2, and here is going to be what? 2 amperes. So what you do when 2 resistors are connected in series, how do we get the total resistance? We add the 2 resistors to get the total resistance. So you first get the total resistance. You're going to add 2 ohms plus what? Plus 4 ohms. You get 6 ohms. The question wants us to calculate the current in each of the resistors. What is the formula for calculation of current? I told you can use this. You can always use this. Resistance is equals to voltage over current. Yes. So how do we get current? Current is equals to what? Voltage over resistance. What is the total voltage there? What's our total voltage supplied by the battery? It's what? 12 volts. So 12 volts. So 12 volts divided by what? Divided by our total resistance, which is 6 ohms. So when you divide here, you're going to get what? 2 amperes. So meaning each of the resistor has a current of how much? 2 amperes. 2 amperes, sorry. Yes, 2 amperes. 2 amperes. Why? Because they are connected in series, and in series there's only one path through which this electricity follows, and the current is all the same in the components connected in series. Yes. So the next question you can be asked from here is question B here. Question B here. Get the voltage across each resistor. Calculate the voltage. Calculate the voltage across each resistor. Calculate the voltage across what? Each resistor. You can look at the resistors. Resistor 1 has a current of 2. And what is the resistance? 2. What about B? It has 2 of a current, and what about the resistance? It is 4. Yes. So the first resistor. Of course, we know voltage is equal to what? Current multiplied by resistor. So the first resistor. So the first resistor has a current of what? 2 amperes. And what about resistance? 2 ohms. So how do you get voltage? You see simply multiply 2 multiplied by 2, you get what? 4 volts. 4 volts. That's the first resistor. And what about the second resistor here? The second resistor has a current of 2 amperes. And what about resistance? It has a resistance of 4 ohms. So how do you get voltage here? 2 multiplied by 4. You get 8 volts. So simply that is how we go through those kind of questions. And I don't think whether I'll dwell much on calculating this. As long as you know the formula, it will be easier for you to calculate that. And so what we're going to do next here, we're going to look at the relationship between current and voltage. Yeah, we can, there is an experiment we usually conduct. We get the relationship between current and voltage. So here, what is the resistance between current? Resistance between current and voltage. Yes, so in this experiment, we're going to measure the current and voltage in intervals. We're going to have an electrical circuit here where we have a voltmeter and where we have an ammeter, and we're going to measure the current and voltage concurrently. What do I mean concurrently? We're going to measure it at intervals. Intervals, when I say intervals, we mean that's where the time comes in. Yes, so we're going to have an electrical circuit here. Yes, of course you should start with a cell or battery, whichever you choose. And of course it has a switch. Our switch is closed. Sorry, I forgot to mention that one. When we have a switch which is closed, this is how it appears. Closed switch. And when the switch is open, this is an open switch. Open switch. Yeah, so there is a difference. I'm going to tell you the difference between open and closed switch. Yes, so we have an electrical connection here. We have a switch there. We have a connection here where the voltmeter is connected across here, and then this voltmeter is connected to our ammeter. And of course here I want us to fix a resistor here. Sorry, I said I'm not good at drawing, but I guess you can understand this. Yes, so so we have our resistor here, our ammeter here, and our voltmeter. What are we comparing? The relationship between current and voltage. Yes, so we're going to measure current and voltage concurrently. Yes, we're going to, this is an experiment we're conducting. Sorry. Yes. Yes, so we're going to measure current and voltage at intervals. We're going to have a table here. Current and voltage. Yes, you know the work of I wish we had a voltmeter here so that we can take the readings. But now that we don't have, we're going to go with the theory ones. Yes, so you can, when measuring this, I'm going to give you the figures, approximate figures. Current was 0.1 and voltage, sorry, we must start with 0. Of course, the origin, everything before starting the experiment, we usually start with 0, 0. Yes, so then the current was 0.1 and voltage here is 0.2. Current 0.3, this one 0.4, 0.3, 0.6, 0.4, 0.8, then we have 0.5, then this one is going to be 1.0. you can look at these intervals. You realize as current is increasing, voltage is also increasing. Yes, so as we increase voltage, current also increases. So from this table, even before drawing our graph, you're going to realize as current is increasing, voltage is increasing, meaning that current is directly proportional to what? To voltage. How do we conclude that? Voltage is directly proportional to what? To current. This means directly proportional. I don't know whether you remember the formula I've been giving you. Voltage is equals to IR, meaning resistance here is going to be our proportionality. Yeah. This one, coefficient of proportionality. Okay, if we allow me use it this way, resistance multiplied by what? Current. Voltage is directly proportional to current, where resistance here is our coefficient of proportionality. That one is from math. Yes, we're going to draw a graph here. I'm going to sketch it. And again, I wish we could draw it, but I'm really sorry we cannot draw it right now. But in your free time, you can try and draw. Yes, so we're going to draw our graph here. And you make sure your graph always starts at 0. And here, we always have x-axis and y-axis. So this is our y-axis and this is our x-axis. Current is going to be at our y-axis and voltage is going to be at our x-axis. Then you make sure you plot them correctly. We're going to sketch this one. This is 0.1, 0.2, 0.3, 0.4, then 0.5. So we're going to have this. I'm only sketching 0.2, 0.4, 0.6, 0.8, 1.0. So when you're going to plot this, it's going to give you a straight line from the origin, a best fit. You draw a best fit. Yes, I'm sorry it's not straight, but when you use a ruler, it's going to be straight. Yes, so it's going to be a straight line. From this graph, we conclude that as current increases, also voltage increases. Current and voltage, they increase as one as the other increases. Yes, so from this graph, you can find the resistance. I just want to conclude here. You can find resistance from the graph. How are you going to find resistance from this graph? By getting the slope of the graph. And the simplest way of getting the slope of the graph is this one. Yes, you get the slope of the graph. Change in y over change in x. Then you're going to get the slope of the graph. For example, here, 0.4 minus 0.2 over, this one is 0.8 minus 0.8 minus 0.2. When you divide that, you're going to get the slope of the graph. So this one is 0.2 divided by 0.6. Yes, the answer you're going to get there, you found the what? The resistance of this electrical connection. Yes, so I don't think whether I'm going to continue from there in this episode. So we're going to finish it there. In our next episode, we're going to differentiate between the one I told you, open switch and the closed switch, how they work, to differentiate between what? Between the complete and incomplete circuits. So for today, we're going to wind up at that point. And thank you for joining us today. As we're going to continue the next episode, please don't miss. So this is Andalusia Academy in Horizon TV. Thank you so much and join us next time.
Are you looking for a school that nurtures your child's academic, spiritual, and personal growth? Andalusia Academy International School, where your child's future is our priority. We offer comprehensive education levels, kindergarten, Pearson I Primary Certificate, secondary and Pearson IGCSE certificates.
We are a school that emphasizes in the Deen and Dunya. It's integrated in that on the side of Islamic studies, we have Quran, we have Hadith, we have Arabic. And then of course in the secular side, we have all the subjects.
We focus on student-centered learning, where we engage our students in different levels. Other than that, we have very innovative teachers who help to cultivate creative thinking, problem solving, which are very, very key skills in our learners, not only in school, but also for their future.
Hello everyone, my name is Aisha Muhammad and I'm a student under Andalusia International School. I've been here for the past 5 years and I'm in year 11 right now, and my experience in this school so far has been amazing.
Admissions are available. Visit us today. We are located in Nairobi, South Sea, Andalusia Academy International School, where your child's future is our priority.